Hello everyone. So I haven't done a video on this project for a couple of weeks, but I have made a fair bit of progress. So a couple of weeks ago I did a video on the memory. So I tested all 8 bits, I seem to remember, and there was 1 bit broken. It wasn't actually a short or anything, there was literally just a tiny little bit I hadn't soldered. So it was just hanging there. It was barely noticeable. But so after that, I was working on the tri-state buffers. So the purpose of a tri-state buffer is to essentially, when it's enabled, you output whatever's in memory, be that a 1 or a 0. If it's a 0, it actually syncs current. And if you disable the board, it doesn't do anything. It essentially disconnects the buffer. So the reason for that is when you have multiple things, like multiple memory or like multiple registers. This is meant to be a register. So say you had multiple registers, say 4, you could disconnect 2 of them, disconnect 3 of them, output from 1, and you can input whatever that's outputting into memory or something else. So yeah, that's the idea. So yeah, these tri-state buffers, they don't actually handle what goes into memory. Memory sort of handles itself, but as a unit, it inputs its own memory if you enable that. So, actually, technically, in this setup, you could it could write to itself. Don't know why you'd want to do that, but it's possible. Anyway, I'll show you this working. So I've got it wired up at the moment to just test 1 bit, but I've tested all 4 bits individually, but I haven't tested them all at once. So that's what I'm going to try and do today. As you can see, it's got a 1 in it at the moment. So this wire here, this is the enable of the buffer. If I take that out, it disables it. It's neither outputting anything or draining current. It's disconnected as far as it's concerned. You can turn it back on. If I change this to 0, so this is the memory, so what's going into memory, you can see it doesn't change because it hasn't actually written that yet. It's still reading the old memory. To write that into memory, I have to take this one low. So as you see now, it's a 1. And I could do the same here in backwards. So write a 1, doesn't actually do anything until you do that. So let's put a 0 back in there. And I want to show you that if I disable the buffer, then try and write a 1. So I've just taken that out. So there's a 1 in memory now, but it's not showing because I haven't actually enabled the buffer yet. So if I enable the buffer, it shows the 1. So that's hopefully working. Another interesting thing you can do here is if we turn this around. Right, so we turn the diode around, the LED around. Now we're going to write a 0. You can see it syncs current now. And to disable that, it still works. It still disconnects it. But when it's enabled, it can sync current. So, yeah, that's exactly what I wanted all round. So, let me turn this off. Yeah, building this board, I had a couple of issues. Oh god, it's not going in. So I originally intended to use diodes to build the tri-state buffer. And I was using them in such a way that they would invert the input. So say a buffer had a 1 here, it would output a 0. If it had a 0, it would output a 1. And because of that, that's why when I made the memory board, I had to, I essentially used the not version of the memory. So if you input a 1, it would read out a 0. And the idea being that when you invert it here, it outputs the correct value. But the diodes didn't quite work. Something I didn't really realize and didn't really pay much attention to is that diodes have a resistance to them. And in this case, it was like 600 to 800 ohm resistance on a diode. And yeah, that wasn't really cutting it because it was still keeping a little bit of voltage behind to keep the gate open. So even though the output worked, disconnecting it didn't. So I had to switch to just transistors for the buffer. and I had to build another board with inverters on it, as you can see here. They don't take up as much space, the inverters, but what they do is they essentially take it in one pin, and the pin next to it is the inverted output. So yeah, that got a bit faffy, but I'm going to try and wire up 4 bits of memory here. So yeah, like I said, I've tested these individually, but I haven't tested them all at once yet, but it should be fine, I hope. So everything's enabled at the moment. These are all low. These are all set to 0, but what appears in memory might just be random to start off with. So yeah, as you can see, we've got 1 bit there that's just already a 1. So if I write to memory, yeah, set to 0. So let's just write in some bits. Yeah, that's correct. Let's write in all the bits. Yeah, seems fine. Disable it. That works. I'm going to try... Actually, no, what I will try is I'll put these ones to low. Wrong one, that one. But I'll turn the diodes around so that they sync current. And that should show that the buffer is both draining and sinking current. Sorry, sourcing and sinking current at the same time. So here's 1, yeah, that's fine. 2, yeah. Okay, so what we've got in memory at the moment... Oh yeah, I'll try disabling it. Yeah, that seems to work great. So what we've got in memory at the moment is 0011. But all these are lit because these two are syncing instead. So if I set these to 1, they would all be trying to source current, but obviously these are reversed. So that's quite cool. This will do the opposite and turn them all off. So I'm happy that's working. That's perfect. Yeah, I'll give you a quick look at the boards. Just quickly, and then I'll do some post. So yeah, I managed to get these quite compact, and actually, I can show you some of the mistakes I made with this. So this was the final board, but I started. What was it? Was that a memory? No, that was a memory board. That's the old. This is my original memory board, I think, and yeah, I added LEDs to it. Then found out I needed a way to get the output out, so that didn't work. And this was when I tried building the buffer with diodes. I've actually salvaged a few bits from this, so yeah, it's not as complete as it was. Yeah. Okay, so you've seen the memory board, it's in my last video, and this is the inverter board. As you can see, it's quite compact. It's yeah, I put them all in line like that specifically to make it compact and take up as little room as possible. My original idea was to, because this has so much free space, put it on the top of the stack, so I can put LEDs and use it as a display as well. But excuse me, but that will make the wire wrapping a bit more difficult because it would have to go up from the bottom all the way to the top, then down again. Actually, unless I put the memory up, it goes from memory down, maybe. I don't know. I'll look into that and let you know in the next video what I do. So yeah, that's that. Let me just secure this a bit before I throw it to the side. Oh gosh, it's not usually so difficult because I don't have it wired up when I do this. Wow, it does not like being forced to do things. Right, there we go. I'll do for now. So yeah, let's open some post. Right. We'll keep that. I'll have to check the video now. And again. Okay, here we go. This is the right side. So I know what this is, and this is actually an accident. I didn't mean to buy this. It was actually an auction. So yeah, like I said before, I ordered 50 Vero boards and they didn't get delivered. I was sort of ripped off there. But I ordered some more from eBay. These only cost a penny because I literally saw this auction, saw it was only a penny, and thought bid for it. You know, might as well. I literally only cost me a penny. No one else bid for these because it was one of those things where you search for something really cheap and buy it or bid for it. Then eBay decides to show you all the actual cheaper ones. So it wasn't much more than you can. I mean, you could buy these straight out for like 20p less. So it's not a massive thing. I just couldn't cancel the bid. So that was annoying. It's weird. You can buy something and cancel the order, but you can't cancel a bid. So I didn't want to get bad feedback or anything. But yeah, so I've got some strip boards now. So I can actually use that strip board cutter I got before. So yeah, I don't know what I'll be able to use these for yet, but I can use them for, you know, simple, small projects. Be fun. What is this? I remember looking this up because it was really heavy. Let's see what this is. Oh yeah. Got some switches. So these are actually to do with the computer project. Well, that is some weird packaging. Woo. Yeah, so these are switches for the front panel to this computer project. So yeah, these are actually... I actually ordered these ones by mistake as well. I mean, I didn't realise until after they were shipped off. And I had to go... I went back to double check stuff, and yeah. So I actually... there's 10 of these, and these were for setting the bits that you want to put into a register or something on the computer. So you actually only needed on-off switches. These are actually on-off-on switches. So that they have a middle state, that's off. Then they have up states. So they're the wrong ones for the job, but they'll do for now. It's not going to be a permanent front panel yet. It's going to be redesigned several times. Yeah, got some of those. And I got 10 of them, but I only need 8, so I'll probably use these for power switches as well, or I don't know, something. I've got more switches on the way. I've got 5 what are they? Momentary ones. So I've got ones that when you flick them, they return to center afterwards. So those will also be for the computer front panel. And I've also got a rotary switch. So the idea with that is there'll only be one display, like in like the hex display I've got. There'll only be one of them, or 2 of them, side by side, but it'll only display one number at a time, one 8-bit number. And the idea with the rotary switch is to switch what register you're looking at, so you can see what's in memory, basically. And I'll unpack them when they turn up as well, but for now, I'll just tell you about them. This, I don't know. I have no idea what this is. What is that? Oh, gosh. They are really small, aren't they? I thought these would be in a bag. If I can, gosh. They should have been in a bag. That would have been so much better. I'll have to put them in one. Are they in a bag? They just shoved them in this IC. See, this is an IC container, but they've... Yeah, they put a bag of things in here. Just trying to get it out. Right. Oh, it is in a bag. Okay, it's good. Okay, I don't know if you can actually see these on camera. Try and get it to focus. Yeah, there you go. So these are actually iron ferrite coring things for building core memory. So I got these after talking to someone on Janky DIY Discord server. Put a link to that in the description, because I do sort of pictures of my projects, intermission ones, sort of like, they're not a whole video, but you can see me do progress a little bit faster there. But yeah, there's actually 5,000 of these beads, and they're for building core memory. So each one of these can actually hold one bit of memory. The idea is you thread wires through them in two directions, X and Y, and then you have a sense line. So when you pass two currents through one of these ferrite beads, one of these ferrite rings, it will switch the magnetic direction of that bead, and it will keep it. And when it changes, it activates a small amount of current on the sense line, and you can read that. It does destroy it, so once you read it, it will switch it back. So you have to write it back afterwards. I won't go too much into detail in this video, but this will be something I'll be experimenting with in the future. The actual wiring that up itself isn't a difficult bit, it's all the support circuitry, which I haven't quite figured out yet, but we'll get there. Yeah, that's all the post I have for today, I think. Thank you for watching, and I'll see you later.